Wiring diagrams may follow different standards depending on the country they are going to be used. They may have different layouts depending on the company and the designer who is designing that. They also may be drawn by different ECAD software such as ePlan or AutoCAD Electrical. So, when you see a wiring diagram for the first time, you may need some time to analyze it and become familiar with its layout and symbols. As there are plenty of videos about vehicles wiring diagrams, ceiling fans, and other appliances out there, in this video, we decided to specifically investigate an industrial panel wiring diagram. However, some rules of thumb will be applied to most of the wiring diagrams in general. So before we continue, please subscribe and click the notification bell and stay with me to the end, as I have very interesting points to tell you. Let's start with an actual example of a wiring diagram. This document includes more than 140 pages, but we'll check some of the pages as the rest of them are somehow similar. Every wiring diagram includes hardware components, power sources, ground chassis, terminals, some wires of course, and numbers, letters, and maybe some nomenclatures. Normally, the very first step to learn reading a wiring diagram is becoming familiar with the symbols of the equipment, and each wiring diagram is supposed to have a page or two for this purpose. This page is known as legend and abbreviation page. To have a quick look at the symbols, you see a three-phase AC electric motor symbol here. This one is the symbol for a solenoid valve. This is a symbol for a contactor. This is the coil, and these are the contacts. Remember that these symbols may have some minor differences in different wiring diagrams depending on the ECAD software they have been designed with. As an example, the fuse in ePlan software looks like this. But in AutoCAD Electrical, it looks like this. By the way, you'll get used to these symbols very soon. Okay, let's start with the first page to see how much it could be easy to read and understand a wiring diagram. First of all, there is a rule of thumb in standard wiring diagrams that you should read the diagram from left to right and from top down, exactly like reading a book. But sometimes designers make some exceptions to have a better layout, such as this page. So as an exception, we should start from the downside, and this is where the three-phase power enters the panel. As a reminder, the voltage level and the frequency of the power depends on the country we are implementing our project. For example, in England or Austria, the voltage level is 400 volts with 50 Hz of frequency. But in the United States, a three-phase power source will produce 480 volts with 60 Hz of frequency. As you see, the power enters the terminal blocks with the X0 terminal strip. The terminal strip is a mark that refers to a group of terminal blocks with the same voltage level or the same purpose. From these terminal blocks, we move on to a 3-pole circuit breaker with thermal and short circuit protection capability. As another rule of thumb, the wiring diagrams are drawn in the neutral condition, meaning that all of the contacts, contactors, circuit breakers, etc. are shown in their normal or non-energized condition. Therefore, this contact is closed because it's a normally closed contact, and the rest of the contacts are open. We have a great video about NO and NC contacts and their actual application examples that you can watch it using the link in the description if you wish. After closing this circuit breaker manually, the power flows towards some power distributor bars, from which some branches can be taken. One of the branches goes into a 2-pole circuit breaker, and from there powers a transformer. If you have noticed, there are some numbers on the wires. These are called wire tags. Wire tags are very helpful in case of troubleshooting, so that when a wire gets out of its connection point, you can easily look at the wiring diagram and figure out where it should be connected again. There are the tags for the devices within the panel as well. If you were looking at the wiring diagram and you didn't know what this device is, then you could find it in the panel using this tag. This transformer converts the 400 volts to a single-phase 230 volts to feed the power receptacle or socket, the heater, and the fan. The ST19 tag refers to a thermostat to turn on and off the heater or the fan on its specified temperature set points. You've also noticed the earthing chassis and its branches wherever it's needed. Before we continue to the next page, you may ask what these numbers on top of the page are. This is a very good question. Actually, these are the column numbers, and they have divided each page of this drawing to 10 columns. As you see, there are some devices in each column, and we can use these column numbers in combination with the page number to address different devices, contacts, terminal blocks, and so on in other pages. Let me explain it by some examples. For instance, the main three-phase power is shown with some arrows and numbers on top of the page. All of them have a 2.0 number just beside the arrow. By 2, it refers us to page 2, and by 0, it points out to the first column of page 2. And there you go, it's our power source on page 2. As another example, the number below this contact says page number 130 and column number 6. I'll turn to page 130, and this is column number 6. And there it is, the same tag, KA1306, as we had expected. It looks like a coil, but not the coil of a contactor, the coil of a relay. And how do I know that? If you have seen the legend and abbreviation page of the drawing, you know that the KA is a nomenclature for a relay in this drawing. Below the coil, you see the 1314 contact of page 2 and also the other NO and NC contacts of this relay, with the addresses they have been used in this drawing. We'll come back to this page very soon. On page 2, the mains power source is feeding a 24-volt power supply, and it provides us with a voltage of 24 with 10 amps of capacity. From there, we have extended this voltage using some terminal blocks so that we can deliver the power to different instruments, PLC cards, PLC CPU, or whatever device which needs 24 volts to power on. But wait, this part of the drawing seems a little bit strange as all of these terminals have the same tag of XC. There are a variety of terminal blocks in the market. In this case, to save some space in the panel, we have used some double-level terminal blocks. They occupy the same space as the ordinary terminal blocks, but we can connect 2 wires to each side of them. In the following, we have a branch that delivers the 24 volts power to page 12, column 0, but with 2 interlocks. An interlock means a condition. Let's turn to page 130 again to see what those conditions are. Did you notice that we have to get back and forth between different pages? This is the only way we have to take to fully understand these drawings. In this page, we have a safety relay here, and it will be used to protect people, material, and the machine itself when the machine is operating. Remember that the designer of this wiring diagram had to refer to the datasheet of this equipment to complete his job. In fact, this is a very important and inevitable stage of designing a wiring diagram, and we should always do the same thing for the rest of the equipment used in the process. By the way, these 2 channels are used to be connected to the safety components at site, for example, the safety barriers. And if the area is evacuated, then these channels will be activated, and as a result, these NO contacts become closed. Thus, the voltage will be transferred to the A1 connection of the relay's coils, and finally, the coils will be energized. Therefore, our 1314 NO contacts of the relays become closed. In this way, our 24-volt power will be transferred to page 12, column 0. Let's pause this part here, and we'll continue the next part by reading and understanding the PLC, VFD, and their power and signal cabling and wiring. I hope you're excited for the next parts of this multi-part series. If yes, please subscribe and click the notification bell to don't miss the next videos.